All right. So guys, welcome to Codementor Office Hours. Today we're very excited to have Codementor PHP experts Ben Edmunds with us today. So Ben is the co-host of PHP Town Hall and also the author of the book Building Secure PHP Apps. Today, Ben is going to chat with us about building modern and secure PHP applications. So Ben, let's do this.
All right. Hey, everyone. Hope you're having a good day today. And let's learn something. All right. So let me share my screen. I'm going to start with, we're going to do the first 30 minutes or so as just a slide deck and kind of standard presentation. And then after that, we're going to aim for around 30 minutes of Q&A. And so the idea is that it should be a conversation. It should be very, kind of back and forth. We'll make sure you learn a lot, but then also the questions you ask will be on the video for later. So when other people watch it too, they'll probably end up with a lot of the same questions you have. So don't hesitate to ask a question, because even if even if you think you should know it or whatever, there's going to be someone else that also has the same question. All right, here we go. All right, can everyone see my screen okay?
Yep, good to go.
All right. So who am I? As intro already said, I'm Ben Edmunds. I do PHP Town Hall podcast with my buddy Phil Sturgeon. I wrote a book called Building Secure PHP Apps. I do a little bit of open source here and there. It's been kind of slack in recent years. My biggest contribution that I'm known for is Ion Auth, which is a CodeIgniter authentication library. And it was the most popular. I don't use CodeIgniter too much anymore. I still support the library, but I don't have a good pulse on the community much anymore. But from the level of support request I get, I would imagine it's still fairly used. And then I'm the CTO at Mindfulware. We're a small tech company. We do insurance and medical software. And it's mostly white labeled, so I'm sure you've never heard of us, but it's fun stuff. All right, today we're going to talk about modern PHP and then also about how to secure PHP. There are a lot of newer things that are recently hit with PHP that a lot of people don't know about and are pretty exciting. This isn't, as the title says, this isn't your grandma's PHP anymore. There's a lot more cool, fast, secure things we can do with it now. Also, with 5.5 and 5.6, there's been a real push towards security. And so I want to let you know about some of the new things that are available, and then still some of the general techniques you can use to secure your existing apps. All right, here's a little bit about what we're going to cover: exceptions, closures, namespaces, statics, short array syntax, PDO for working with SQL and relational databases, and then lastly we'll go through some security topics. All right, let's start out with some of the new stuff that PHP has is actual legit tools. We now have a built-in server for debug. We have Composer for package management. Package management doesn't suck at that. And unit testing. This is unit testing has been a real push in the community in the past couple of years, and it's really exciting to see. For years, Rails and the Ruby community was really big on test, and everyone kind of looked down on PHP as being, your script kiddie language, because really it was, for the most part, a bunch of quick hack scripts that no one really cared if they functioned properly. But in recent years, there's been a lot of tools and a lot of, real education and a push in the community that, hey, it's time for PHP to step up, and let's start unit testing. All right, first let's go over exceptions. Some of this, hopefully, some of you already know, but I'll still cover it anyway for those that don't. An exception, of course, is when something bad happens. This is what it looks like to catch an exception. It's a try-catch block. So you're going to try to do a certain thing, And then, especially if it's a library or whether even PDO, some of the internal functions now, instead of just returning an error code back, they'll actually return an exception, which is basically a formal way of telling you, hey, something went wrong here. And then it can return back a certain type of exception, or it can return messages in the exceptions to tell you what went wrong. So instead of constantly trying something and then checking the response and seeing if, did it return false? Did it return false? Let me go do this other error function call, whatever. You now have a formal way of bubbling up exceptions, bubbling up errors. Exceptions aren't really new, but they're really just now starting to catch on. For years, you would hardly ever see anyone use one, but now it's pretty rare to not see exception handling in any modern day library. So the real key is the exception objects that's returned. You can have different exception objects. It doesn't just have to be the generic one. And then you can pass through messages. And you see there the die get message. That's, of course, not how you'd want to handle it in your code, but you get the idea. Closures. If you've ever used JavaScript, you've used closures. It's you might know them as anonymous functions or callbacks. The idea is that we can now have functions that aren't named. So here is a basic example. This is a Laravel style, just because it's easy and you can easily get the idea. Here we're defining a route. The first parameter is passing through just a /, which is the root, and then we're going to pass through a function. So in previous years with PHP, you would have to name that function. So you would have, function return index, and then you would do this route get / return index. And that's kind of the waste, because we're never going to use return index again. We just want to use it this one time. And so here we can pass that through, just a one-time use, and it's there. So I'm sure most of you use JavaScript. It's very similar to JavaScript's implementation. There is some difference in the scoping, but that's a little outside of this discussion. But I'm sure you've had the this problem in JavaScript, where the this constantly changes based on the scope of how deep your callbacks are. PHP doesn't quite have that issue, but then it also has a use command, which is saying, hey, inside of this callback, I want access to these external variables, namespaces. All right, so the idea behind a namespace is that we have all these different pieces of code. They're, whether we have a form helper, we have a database object, all these type of things, and at some point it gets hard to know what's where, or let's say we use two different libraries and they share the same class name. That's going to interfere with each other. A namespace is just a logical grouping, a container for similar objects. What it looks like is here. So in this case, we're going to define that the command class will be a part of the Illuminate console namespace. And these namespaces can go as deep as you want. So we got Illuminate console command and then something else under that. But the real idea here is that it's all under this one container. That gives us that separation, and it also makes it easier to figure out what we're working with. So if we're going to do IOC, we're going to inject different things in our controller, for example, we can check back and make sure, are we using, is the DB class the Illuminate DB class, or is it some other DB class that somebody's trying to put in that's Illuminate? Maybe we'll bootstrap it a certain way. If it's, random class B, maybe we'll just use generic bootstrapping or PDO or whatever. At the bottom here is how you would use this. You just do use Illuminate console command, and then you can call your class like normal. And it just tells it, hey, we're going to be in this namespace. All right, I'm going to have a drink of coffee real quick. All right, statics. This tends to get a little hate in PHP world, simply because when we first got statics, a lot of people went really crazy with them and were like, hey, everything that could possibly be a static, whether it should be or not, let's make it a static. And no, that's not a good solution. The idea behind a static is where you would previously have had maybe procedural function calls that were related, but didn't need, object-oriented, didn't need inheritance, didn't really need a class. They're just kind of random functions that are related. That's really where statics fit in best. So you can say, let's say you have a form helper. It has shortcuts for creating a form, for creating inputs, things like that. But there's just not exactly a scope that you need to keep track of. So you don't have a form object and then you build on that. You're just calling these functions inside your view in order to help you build out your HTML, things like that. Those would be perfect for static functions because they're self-contained, they don't need that root scope, they don't need inheritance, you're just calling them, but they all should still be grouped together because they're all helping you handle this HTML through the form. And so that's a good example of what a static is good for. What a static is not good for is retaining state. So if you actually do want to build an object where you can add and remove things from it, and you retain the scope, you retain the state of that object through time. That's not what a static is for. There are ways to kind of hack around that. Laravel gets a lot of hate for the way that they use statics because it's not exactly perfect. It's not how statics are really meant to be. I like Laravel personally. But really, it's just a syntax thing. It's just to kind of speed up development the way they use them. It's a really clever use for it, but in your own code, it's probably best to not try to be too clever. Stick with a convention. If you want to use statics as a shortcut for your IOC, that's fine. Just don't get too clever and confuse the next person that comes behind you. So here we have a get class on a route, or get method on our route class, and to call that static we just do route get. And you can see the difference there is the double colon instead of the arrow, and that tells it that it's going to be a static call instead of a normal class call. You can also tell here we're calling route directly. Usually with a class we would have to say new variable whatever equals new route, and then we would do new variable arrow get. Here we can call get directly on the parent class without having to define a variable to stick it in. All right. Some problems you'll notice, or say problems, limitations. There's no this object inside of the static. And then there's difference in the scoping of variables depending on if they're defined inside or outside of the static, if they're part of the parent class or not. And so it's at least worth your while to read up on how the scoping of things work inside of statics. Short array syntax. This one is very inconsequential, but it's one of my favorite new things that recently hit PHP because I am lazy, and because also it's a little closer to the JavaScript syntax, which is nice since I'm in JavaScript all day, and I'm used to typing this way. So previously we would have array equals, and there's this array function thing here. Now all we have are these brackets. Super similar to JavaScript if you're used to that. It's just a short, quick way to define an array without having to call the full function name. Again, it's super inconsequential, but it's something that I'm personally excited about because it makes a few extra keystroke saves a little faster, things like that. PDO. So classically, PHP's database handling kind of sucked, but now with PDO's been out for a few years now. It's slowly gaining popularity, and recent years, I'd say really in the past 2 years, it's pretty normal to see PDO use. And it is just a good class, a good way of handling database abstraction. And it gives you a good database layer that works across databases, so you can have Postgres, MySQL, etc., and have the same API for interacting with them. That said, it's cross-system. These are the databases that it supports right now. I'm sure this will be, added to as other databases become popular. For the most part, though, this is going to handle any relational database that you're likely to use. I've never used any relational database outside of this group. So it improves on the binding, and it really just promotes safe binding. So that will handle a lot of SQL injection attacks for you automatically if you use this. Here we have an example of a prepared statement. So we're going to do db prepare, select star from users, where ID, and here's the magic, :ID. So that's just a placeholder for a variable. We then run statement bind command. And we're going to say, hey, for the ID in here, actually give it the ID variable, and then execute. This might seem kind of dumb, it's a little extra work. Why not just stick the ID variable straight into that query? The difference is when you do it this way, it's going to automatically escape it for you. And it's also going to run through a different execution loop, so that if you had a where or where and where, something like that, it would not allow you to break out of that tree that it should be in. Whereas if you're just writing a straight SQL query, if it's not escaped properly or whatever, you can easily say, okay, that query's over here, now let's delete all your users. Binding the parameters stops that execution path from happening. Totally recommend it. Anything that you can use that's built into the language to make your life safer and easier, totally do it. Don't try to handle anything yourself that you don't have to. Because as we all know, we write bugs, and you get in a hurry, it's late, you have to get a site back up. You're going to make mistakes, or you're going to push something that is a hack. Don't rely on yourself when you can. Let the language handle the security for you. All right, now we're going to get to the security section here. That was a super quick overview. I hope I spent enough time so that you're not completely lost. But if you are, write down a question, and we'll take it at the end for Q&A. All right, some of the biggest issues that I see security-wise, and OWASP would tend to agree with these. OWASP is a foundation, I believe, or an organization that promotes and helps with security issues. They currently have a top 10 list, which is where they're kind of the authority on security issues. And their top 10 list is pretty close to this. This is a little reduced. I took off some of the issues that I don't see very often, and those can be covered elsewhere. But I totally recommend, if you're worried about security or if you're interested in it, check out OWASP. It's a great resource. All right, SQL Injection, HTTPS, password hashing, Authentication, safe defaults, cross-site scripting, and cross-site request forgery are the biggest issues that I personally see security-wise in web apps. We'll go through what each one of these are. All right, as we already covered with PDO, it makes it super easy for you to bind your parameters. So escaping input before it goes into your database to protect yourself from SQL injection. The idea behind a SQL injection attack is, hey, we're taking this data, but someone can manipulate the ID. So let's say a form post is where you usually see this. Somebody takes in a form and they assume that, hey, because it was posted and I had this hidden ID variable filled, so you just have the hidden input with your ID, I don't have to do anything to that. because it was posted and it was hidden and the user can't change it. That's totally not true. As you probably know, anyone can just copy your form, or they can inspect it in their web browser and change anything they want to and then submit it. Any input that comes from a user, you just simply can't trust. If it came from a user, it could be bad. It could be malicious, or it could just be incorrect data. There are a lot of times where, let's say you have a varchar 10 in your database. If you don't properly check that, what happens when the user sends through 11 characters? What happens when that max length on the input field isn't recognized in IE6? Things like that. You really want to think through, this is the data I expect, this is the data that is valid, and then try to handle all that through validation or through typecasting, through trimming, things like that. Also, things to keep in mind is, so in that data length example, MySQL, if you send through 11 characters for varchar 10, it's going to just truncate to 10. So maybe that's not a big deal, so the data gets truncated. But with Postgres, if you do the same thing, you're going to get an exception thrown from your database. And then your insert doesn't happen, or your update doesn't happen, or whatever the action was. So now you have lost data. So it's always better to handle any kind of restrictions on that data in your code where you can. That doesn't mean you don't want to follow it up with constraints in the database, but for the most part, you want to try to not allow invalid data to even get to your database. That's asking for trouble. Escaping's huge, as we mentioned. Here, bind param for PDO is going to handle it for you. If you're using a different library or an older library, PHP has built-in functions for escaping. You can use that through PDO, or if you're using something older like MySQLi or anything like that, it has its own functions you can call. So totally try to use the built-in functions for that. They're going to think of more use cases and hit more different issues and servers than you ever will, and they're going to handle things better. So where possible, use that. Don't use some funky regex you thought up this morning. Escaping output is the next biggest thing. So just because someone's able to they type in their name and they send it through, doesn't mean you should display that directly back to the page. Because what if I type in HTML, or what if I type in JavaScript even? You don't know what that'll do when it's displayed back. HTML entities is going to be your go-to function 90% of the time for cleaning data up before you put it back to the screen. All right, HTTPS, SSL. What's it good for? Why do you want to use it? It will encrypt traffic across the wire, and it's end-to-end. So that means that you can know, hey, this is the sender, this is the receiver. Anything that goes through this pipe once the connection is made is going to be secure. No one can look in on this. It's going to be encrypted. All you have to handle in that case is the handshake between the two, and then you can trust the data. OAuth 2 now requires HTTPS. The only reason I say that is because I'm sure most of you have heard of OAuth 2 and know that it's becoming the new real accepted standard for API handshakes and communications. OAuth 1 would actually try to encrypt some of the data. It didn't require HTTPS. It was pretty hacky the way it tried to make sure everything was secured across the wire. Now things are simpler. Just use HTTPS and you're going to be safe. There's still some things to think about there. You have to, you want to use a certificate of authority. You want to make sure that you have valid certificates on each side. There are still ways around it. Also, who knows what the NSA is doing with the things we've heard about recently. But for the most part, if you want safe end-to-end encryption, HTTPS is going to be your easiest and safest option. It can be expensive depending on where you get the certificate from. For example, average that I've seen is probably around $1,000 for a cert. But then also a lot of shared hosts will have special plans. For example, I use DNS Simple for my DNS, and they offer, I think it's $20 a month for an SSL cert, and then you're basically just paying per month Whereas if you buy the full one, you pay per year. If you buy it directly from Certificate Authority, of course, it's going to be a little safer. You can transfer it between servers and things like that. You can change it between separate DNS hosts. But if you're looking to save some money, I really recommend checking out your host. I'd hate for you to just not have HTTPS because it's too expensive. There are usually cheaper options out there. There's also for internal, so like an intranet. There's also self-signed certs. You don't really need a certificate authority for that. You can actually just create your own cert, host it on your network, and then have people download it to their browsers. For a public website, though, that would not be a good solution because a good user will know not to trust some random authority from a website they don't know. The cert, the HTTPS, is also what gives you that nice green lock screen telling your users that things are secure. All right, authentication is the next item we'll cover. So there's more than just your login screen to your authentication. One thing a lot of people will do is they'll say, hey, let's log in the user, the users, whatever, let's take them to the admin screen. But then on that admin screen, they don't necessarily check again that the user's an admin. They just assume that because the user made it to that screen, they are an admin. What that doesn't do is that doesn't protect you from a user that just goes and guesses that URL. Or let's say Google scrapes that URL somehow, and now there's a link on Google to your admin panel. Anyone can access that. That's not cool. What you want to do is, usually, I do it at the top of my constructor. So let's say I have a controller, and it's just my admin panel controller. The very first thing in the constructor, I'll pull in the current user, and then I'll check and see, hey, is this user authorized to access this controller? If not, return some type of pretty error to the screen, take them to an error page, or take them back to where they should be, something like that. Try to check their access as soon as possible. Don't wait until right before you display the view, because if someone comes back later and there's an error, let's say someone ends up throwing a return sooner for some reason, then boom, all of a sudden your users can access it. The sooner you take them out of the execution path, the safer it's going to be for future changes. Also, it's going to be more performant. There's no reason to make the user run 20 SQL calls and then redirect them to an error page. Just go ahead and take them to the error page. Another issue with login that a lot of people miss is brute forcing. If you don't have any protections against brute forcing, it is trivial to break anyone's account because people use one password everywhere, and it's probably in a list of the 100 most popular passwords somewhere for like 90% of your users. It's really sad. So if you don't check against that, someone can run a brute force login tool against your site, and they'll be in users' accounts in minutes or hours usually. What you usually want to do with this, and this is a super simple code example to show you what I mean, but the idea behind it is that you're going to track their login attempts within a certain period of time. So let's say we probably want to track, how many login attempts within 10 minutes. It needs to be a big enough period to slow down anyone that's trying to hack them and keep it from being beneficial to keep going. You have to make it take too long to be worth it. So if you can only do, let's say, 5 tries in 10 minutes or 10 tries in 10 minutes, whether you think it's reasonable, that's going to be too much of the cost to the hacker to continue. So just make sure you have some type of protection against brute forcing. The way I've done it in the past is I'll keep an IP list as well as a username or email list. So that way if you see the same IP trying to hit several users, you could also stop that. You want to be a little more careful with that if you have like a company hitting you, because a lot of times companies will all show up as from the same IP because they all route through one public IP to get outside of their building. So if you do block by IP address, I would make that login attempts a lot higher than if you're just blocking by email. But I would definitely recommend doing both in case you have a malicious user trying to hack your login. All right. PHP now includes safe password hashing built in. So what this means is you don't really have to worry anymore about, do I use MD5 or SHA-1 or bcrypt or whatever. PHP now has it just straight up built into the language. It's going to use the newest, most secure, or most accepted hashing algorithm, and it's going to give you a common API to use now and in the future for your password hashes. Also includes functions to verify the correct password. So in this case, at the top here, this is what it would do before, let's say, the password stored in the database. And then at the bottom, this would be the login function. And so we're going to pass it whatever the user typed in on the login screen. And then we're going to pull the password out of the database, and we're just going to see if those match. This will be a hash stored in your database. It's not going to be a plain text password. There's also going to be a unique salt in this algorithm. So if you even encode the same password twice for different users, it will be different each time because there's a different unique salt encoded into that hash. Now, if you do verify, it's going to pull that salt back out. That way it can rehash your password with that same salt. So it's a pretty neat trick the way it's all in one string, and you can even tell it when you look at the string because they're separated by dots, but it makes it a lot easier for you. All right, next up is safe defaults. So I should probably start talking a little faster because we're getting a little over in time here. One common problem is that people will define and use a variable directly within the same logic loop, but you don't know how that variable might change over time. So let's say you expect the variable to start as a certain value, but then a user gets in through a different path. So let's say they come in through a different controller method. They didn't hit your home controller, they went straight to your admin controller, and that means that variable now doesn't have the default value you expected. It's best to just go ahead and define what you want that default to be as soon as possible. I recommend at the top of your controllers when you can. If it needs more mutations or work done to it, then do it in your constructor. As soon as you can, though, set up all your default values. That'll also save you if you're in a loop. So let's say, here in this for each, we're defining something equals the foo as something equals bar, then we do something else to it. This will leave you vulnerable because let's say before this or after this, whatever, we get to something and we expect it to be false by default. But here we came through a different path, like I said before, and now we didn't hit that initialization for some reason, and now it's empty or it's null. That could throw your logic for a loop if you're not handling that properly. It's a really simple example, but I'm sure most of you have ran into this problem before, where you expect a variable to be something by default, and then it's not. The easiest, safest, and most verbose way, because being verbose is usually good. It can be bad, like when you use Java or Objective-C, but for the most part, it's a good thing because it's easy to tell exactly what's happening. I guess a better way to put it would be try to be very explicit with your things. So it's easy for another developer to come behind you and say, oh, okay, the default value of this should always be this. They shouldn't have to know what's going on in that for each to know what it most likely will be when it's done. All right, let's finish up here with a couple common hacks. Here's cross-site scripting, or called XSS. Here we've got a URL that is it's just doing paging, page num equals 2, per page equals 50. If you don't properly escape those values coming in, so let's say you just automatically assume that they're going to be good values, as we talked about earlier, or even if you don't necessarily define that they have to be numbers, you can typecast them to ints to protect yourself here, since these are going to be numbers. But let's say someone's able to change this, and they change it to page number 2 and action equals delete, and your page takes that for some reason. If they can guess, or if they can use your site, and then they can just watch your URLs and see what's happening in your URLs to perform certain actions. So let's say they go create a test account, and they delete a user, and they say, oh, okay, so the URL to delete a user is this. They then go generate that with someone else's user ID in the URL. They send that to them somehow, either through a link on a site or a phishing email, whatever. They get this link into a user's hands. The user clicks it. The user is already logged in. They have a valid account, right? So the delete page is going to automatically assume that they want to delete their user because, hey, they're logged in, they had session data, whatever. But they came from an invalid URL. The system wasn't expecting that. Boom, they just click this link, and now their user account's done. They were deleted. Persistent SSS is the same idea, but it's data that's saved to the server. So maybe it's not, you don't send an email with a link to someone. Maybe it's a Facebook status, for example, and you're able to put a link in there, or you're able to just change data in there. You'll say you throw JavaScript in there, whatever. And then you post that. Someone comes back to look at the page, and then they're presented with the HTML or the JavaScript, and then it does something nefarious to them. Most of the time, to fix that, you're just going to need HTML entities. So anything that's displayed back, whether it's from a per page get var, or whether it's from the database, you can't trust it because you didn't generate it. It came from a client or a user somehow. You need to escape that before you display it back. All right, CSRF is similar, but it's slightly different. So the way this works is, let's say we post a form, or let's say it responds to anything. It's users 12 delete, similar to the other example I gave, but it's a little different. I hope you can catch the difference here. If you have a post, put, update, or delete action, and it doesn't necessarily have to be that you're responding to these HTTP verbs, but that's the actual action you're performing. If you're changing data, then it really needs to be behind a form in your system with a one-time use token. These are typically called CSRF tokens or announces, and it just means that for every action, we're going to make sure that it was initiated by the user and that it came from a form that we supplied recently. Here's an example in code. So here, this would be used as, like, let's say, a hidden field in the form. We're going to generate our unique token. We're going to then save that to the session, and then we're going to return it so that it can be put into the form. Then when that form's posted, we can check that the token in that form matches the token in our session. This is the simplest way to do it. You're just saying, hey, each form's good once. This is what it is. That can cause a big problem if you have like 2 forms on a page, or if you had some AJAX stuff going on. Simple solution in that case is usually to just store an array of valid tokens in the session, and then have a garbage collection routine that deletes those after so many seconds or minutes. So let's say, all your tokens are good for 5 minutes, and then they expire. Makes sense? All right, so PHP now has some actual legit tools to make your life easier. Ruby for a long time had all the cool toys, and we were kind of jealous, so now we built them ourselves. We now have the built-in server for local development. If you want to test your site, you want to try, let's say you want to try the site real quick, but you don't want to set up Apache or vhost or whatever, you can just run PHP minus capital S, and then your host and port. And it's going to start up a server in whatever folder you're in. It's going to serve that out on that port. So then you just go to your browser, type in localhost 8000, and you're going to see that site. It's not something you would ever want to go to production with because it's not resilient. You want to use Apache or Nginx or something like that. But on your local, it's a great way to test something. I also really like it, let's say if I'm switching between projects, it's nice to be able to just switch to a new project, type that in, and then hey, I can load up the project directly. I don't have to worry about keeping a list of vhost or host entries or anything like that. Just type it in and I'm good to go. Composer. All right, Composer is finally a good, sane package manager for PHP. It's not Pair. A lot of people wonder, Why do we have Composer when we've had Pair all these years and Pair always sucked? Well, Composer is actually good, secure packages with the same format. So all you have to do is define your Composer JSON file. Then it's just JSON data, which you're used to. If you either use JavaScript or a computer, probably, in the past couple of years. You define what packages you want to pull in, and then it's a couple simple commands to get set up and going. There's different commands for updating new or for just installing any changes since you last used it. There's some advanced stuff you can do, like there's a lock file so that you can keep your exact system, your exact versions in place, and then you can propagate those to your servers, the rest of your team. If you just do an install, it'll update via the lock file. So you know that your version numbers match what you expect. Also, it has an autoloader built in. So here we can just say client equals new services Twilio. It'll know how to look up that file based on the autoloader, and then you can just use it. So you don't have to worry about trying to figure out the whole path down to this certain class inside this certain library you never used. It'll handle that for you the way it's namespaced in the autoloader. Unit testing, like I said earlier, it's really exciting that PHP is finally getting on board with unit tests. So a lot of tools coming out. This is just a very small selection, some of the more popular tools. There's strict unit testing like PHP Unit. There's browser testing with Selenium. There's BDD test with Behat and Codeception. There's even specs like PHP spec. And all it is different ways of making sure that your program does what you expect it to do. Here's a very simple test case where we just say, this is going to be a PHP unit class. We're going to test verify, and we're just going to assert true that the authentication would verify. This is pseudocode, but you get the idea. So we're going to implement whatever class we're testing. We're going to call the method that we're trying to test, and then we're going to here assert true. So that means assert that the response of this function is true, because that's what we would expect in this case. You could assert false if you expected false. You could also assert that it equals a certain value, things like that. The real idea behind a unit test is that every component of your code, so let's say like your models or your libraries that you write for yourself, they behave properly to valid and invalid data and return what you expect in each case, so that you can be safe in knowing that as you use that class throughout your system, it's going to work properly. Another piece on top of this would be acceptance testing. It's used most likely. There's other types of tests. There's integration tests as well. Acceptance test is the most likely one you'll see, so that's like Codeception or BDD, where you're saying not only do these individual components work, but the entire system together works. So usually that would be an in-browser test, or if it's a command line tool, it would just run from the command line, and it would run your entire system and then check that the interactions between them and the output, the final output, is what you expect of all these pieces mixed together. Usually you want to have a good mix of unit testing and acceptance testing, so you want to say, hey, all of these pieces, all of these classes work exactly how I expect them to on their own, so I can feel safe using them throughout my application. And then you do the exceptions testing to make sure that your business logic, the final output of your application, with all the pieces mixed in, matches what you expect. To run your test, all you have to do is PHP unit test, and then it's going to go through, it's going to run all the tests in the test folder, and you get a nice little output of how many test insertions you had and if you had any errors. Resources. There have been a lot of very helpful resources come out for PHP in the past few years. PHP.net, as always, is probably your best resource for looking up any functions or methods or anything you want to use that's built into the language. Their site's been recently updated, which a lot of people hate, but it looks pretty good. I like it. There's a lot of modern frameworks out there now, so there's not just CodeIgniter and Kohana anymore. We now have Laravel, Symfony 2, Swan PHP, things like that. They cover a wide variety of needs. For example, Aura is pretty much just a bunch of classes that you can use by themselves or together as a framework. Whereas Laravel is kind of your monolithic framework that does everything and could be used outside of it, but it's really made to be used as a complete package. And then Slim is basically PHP's version of just like the smallest framework you could possibly have. You just have routing and views and not much more. PHP the Right Way is a website and recently a book on LeanPub that I highly recommend. So it's compiled by Josh Lockhart and Phil Sturgeon, and so the community has gotten together and worked on this resource of, hey, this is what modern PHP looks like. This is how you do things in PHP now. And then, of course, I have to let you know, my book is Building Secure PHP Apps. It's a short read. It's around 100 pages, and it'll just give you pretty much the bare minimum that you need to know. And it covers basically the topics we covered here in a lot more detail. If you use the coupon code Codementor, you get $3 off. That's the full URL at the bottom. All right, and now let's have some fun. Let's do Q&A.
All right, guys, let's do this. Any questions for Ben? Jonathan, do you have any questions for Ben?
Yeah, I had sent a few ahead of time to Ben. One of the things I was wondering is just, and maybe this is outside of the scope of this discussion, but was, let me just pull this up here. I guess I'm wondering how far the average PHP developer has to go with their DevOps knowledge. And I know that that's going to be different from one company to the next, because you might have a specific DevOps person at your company. For myself, I definitely don't have that. I'm kind of doing the development, but then I'm also managing my servers. Personally, I use Linode or DigitalOcean or something like that, and I'm building up and provisioning my servers. And it's kind of this thing that I'm left a little bit uncomfortable with. Like, am I doing it right? I'm following the guides. You know, I read the tutorials, and I'm just a little bit like, how safe is, say, Ubuntu out of the box? And I don't know. Maybe Ben, you want to maybe have some thoughts on that. You know, am I trying to do too much by provisioning and managing my own servers, or what do you do?
Yeah, so I've been lucky or unlucky enough to usually have some type of ops person that I can rely on at most companies I've worked with. So admittedly, my server knowledge is pretty lacking in general. What I have done in the past for like side projects is I'd set up the servers, and I'll do pretty much what you did, read the tutorials, things like that, and then I'll pay someone, I'll hire someone for maybe an hour or two, an ops guy, to come behind me and to check the server. Also, what I've done in the past is I've hired someone. I think it took him like 4 hours. I had him set up a base box and secure it for me. I was using DigitalOcean, and so now I have the secure image, and I can just copy that image and keep going from there. Of course, you might want to do that periodically because things change. There are new hacks and stuff. But even if you're doing it all yourself, I would totally recommend just having someone consult behind you and make sure it's even if they come in and they say, oh, everything's good, at least you have that peace of mind then. You get to sleep well at night and to not sit up worrying that you forgot to check something in your firewall. So I totally recommend that. There's a lot out there we have to learn in general, and it can be hard to know everything about servers and everything about the back end and everything about the front end changes weekly. And yeah, so I personally like to just get help when I can. Also, I see more hacks that have to do with actual code. I've seen several server hacks over the years, but it's more rare, and it usually takes a higher level of work, unless you had something like WordPress, which again usually gives people access to your base server, which they'll hack, but again, it came in through the application. So if your application is secure, it's a lot harder for someone to get straight into your server, unless you have like SSH with no password or something crazy. If you're using common sense, most of your hacks are going to come in through your application code, at least in my experience.
Yeah, no, that's helpful, Ben.
All right, so we have a few questions here from Will Parker. What's the best correct ways to store passwords in a database? So I would totally recommend using the native PHP functions now if you're on a newer version of PHP. So it's what's recommended most right now is bcrypt, and that will hash your password as a one-time use hash, and it will keep your stuff secure. It's not going to expose plain text to your database. You have to think about if there's a way for me, if I had access to this database, or if this is my database, if I had a way to open this and I have a way to figure out what password this is, either because it's a hash with no salt, so then I know, like, oh, it's MD5, so I can just run this, and okay, yeah, I know what it is. Or if it's a reversible encryption, it's not a hash. So if you can encrypt and decrypt it, that's bad. You should never be able to figure out what the password is. It should be a one-way thing. All you see is the hash. You want to be able to recreate that hash. That's why you have a unique salt, and then you store that salt. And what a unique salt is basically just a random string that you throw into the password so that it's going to be a different hash for each person that has that password. Or else you could say trend, you could go put in a password, and then you could go find everyone else with a matching hash. But if you also do a unique salt, that would not be possible. Hopefully I covered that well. One other thing on that is how do you, let's say right now you have MD5 as your hashing algorithm. What's the best way to upgrade that? If you can, it's probably technically best to invalidate those passwords and then rehash them the next time that person logs in. So you can say, all right, there's a new flag on the database that says MD5 or bcrypt. Next time they log in, if it's MD5, we're going to rehash as bcrypt, resave that to the database, and then set that flag to bcrypt. So from now on, when they come in, they're going to just use bcrypt. They have an updated hash. Boom, we're good. A big issue with that, though, is let's say you have a lot of users, you have a big database, and the users don't log in frequently, or you're going to have a lot of expired tokens. So if your database was hacked and someone got a hold of it, you don't want to lose, 3 years of users' passwords for all the users that haven't logged in recently and had their hash upgraded. So what you can do is another failsafe is you can actually just bcrypt, or whether you're using, I say bcrypt because that's currently what's recommended by most security experts. So you can decrypt your actual MD5 hashes. And at that point, your password is your MD5 plus your bcrypt. So you just run a command against instead of only running through bcrypt, run through MD5 first, and then pass that MD5 hash to bcrypt. And you're instantly secure across all your passwords. So it's going to be a little slower, but actually slow is good in login, because the longer something takes, the harder it's going to be for someone to get around your security or hack it. Login is one place where slow can be good, and good hashing algorithms like bcrypt have a cost factor associated in there where they're going to take a certain amount of time by design. They won't be super fast, because fast is bad. It means more attempts against your passwords. All right. So do we have any other questions? So how do organizations like Facebook, etc., keep track of previous passwords and similar passwords without storing all that data? Isn't it storing all that data just making yourself a bigger target for hackers? So I don't know how Facebook in particular does it, but I know how I've done it in the past, is that I will store the salt and the password, and then whenever you go to change your password, I will just run that again with the same salt and see if the hash matches any of your previous passwords. So let's say you have the database table with the last 5 passwords, and we're talking hashes here, not the actual password. So we have the user ID, and then we have the password hash, and we'll store the last 5 of them. Then when you go to change your password, we just rerun that with the same salt and check to see if it exists in that table for that user ID and that hash. Make sense? So you still don't know what the password was, because you don't ever want to know what the password was. But by rehashing with the same salt, you can tell if it matches any of the previous hashes you had stored. All right, next up is how do I prevent forms from being submitted twice when a user reloads a page or gets the option to resend? That's actually the CSRF token we discussed will actually handle that for you if implemented properly. So if you have a check on there that it's a one-time use token, if you were to try to submit that form twice without reloading the form before, it's going to stop you from doing that. Another option to prevent people from accidentally doing that, it's not for security reasons, but it's for your UX, is just use some JavaScript that says, hey, when I click submit button, let's gray it out while the next page loads. And that adds a little help to your users so they don't think the page isn't loading and click it again, and then they see your one-time use token error. So do that to help their user flow in case the connection's slow or something like that. And then that token, when implemented in the form, will keep that same form from being used twice. Jonathan posted a good link in the chat. It's if you're on less than PHP 5.5, IRC Maxwell, who is Anthony Ferreira, has a password compat library that will give you, I think it's PHP 5.3.7 and up. It will implement the same core functionality for you in a library form. So if you're between 5.3.7 and 5.5, you can still use some password hashing and verification functions. Question from Tom: do you have any security advice for developing with Laravel applications? Actually, luckily for the most part, Laravel handles most of this for you. It's usually pretty transparent. So when you say to the database, it's going to automatically escape things unless you use straight up queries. So if you actually use the functions built into Laravel, it will escape them for you. If you use just the query function and you're building them by yourself, then you have to think about it. But for the most part, you're not going to be doing inserts for updates or anything scary. Well, that would only be for some crazy report or something where you have to do a select with 1 million joins, at least in my experience. For displaying things back to the screen in your views, for example, if you're using Blade, you have the double curly to echo out your variables. There's also a triple curly, which will escape those for you when you display them back out. So for the most part, you want to use triple curlies in your Blade views, and that'll handle your output escaping for you instead of having to throw in HTML entities everywhere. That's most of my recommendations for Laravel, the ones that people might get tripped up on. You have the built-in Authentication class, which handles the password hashing and verification for you. And then there's several good libraries for CodeIgniter to handle passwords and login and authentication. Sentry being one that I use a lot myself and can recommend. Their docs might be a little lacking, but the code itself is good and well maintained. New question from Jeremy. What are some newer PHP features that many people might not know about or use on a regular basis? Hopefully I already covered a lot of that. One additional thing that I would recommend is just going on, say, the 5.5 changelog and the 5.6 changelog and seeing what's changed and researching each thing. I just covered some of the high-level topics, but there's just going to be things in there that you're like, oh, this is here, I didn't know that, and it's going to make your life easier. So it's never going to be a bad investment of your time to go read through a changelog for a few minutes and see what stands out as a pain point you've had or something that would really help make your day-to-day a little faster, a little more efficient. So I'd totally recommend that. Let's see. Sorry, I'm just sorting through my questions here. All right, so Jonathan asks, I have an app that uses SHA-512 for password hashing, but he knows bcrypt is preferred. So how big of a deal is it that he upgrades immediately? SHA-512 is not horribly bad, and if I remember right off the top of my head, there are no known exploits for it right now, as long as you're using a valid, unique salt. If you're using it without a salt, it's horrible, and you should go change it today. And you should probably just do the vcrypt hashing of that hash that I mentioned earlier. If you are using a valid unique salt, then you should be fine. As far as I'm aware, it's still safe. It's just not preferred because of the algorithm's not as complex, and it's not as good for the future. Makes sense. Let's see. So what's the most common reason a hacker would attack your application? Is it to acquire data or to cause damage for the sake of it? A lot of it depends on your type of application. So if you collect, credit cards or sensitive account info, usually it's for the data. That's how most credit cards get hacked. Is someone will take the database. There was not proper encryption or handling of the credit card info, and then you can pull that out of that database. That's a pretty big motivator because you can make a ton of money that way. But another issue is you just have to factor in for the malicious user, maybe the security expert that wants a name for themselves by hacking your website and writing a blog post about how they hacked your website, or just the 15-year-old kid that just downloaded Firesheep and figured out that they could watch people's internet traffic because you weren't using HTTPS. There's a wide variety. If you're handling sensitive data, though, I would totally be most worried about the data. At the end of in game, it's not going to ruin someone's life if their Twitter account gets hacked, but it could if their bank account does. So it's you have to kind of put your security efforts in depending on how sensitive you think your data is. But there's it's totally nothing wrong with being more secure than you need to be, if that's even possible. I think that's all the questions I had written down here. Does anyone have any more?
I had one more question, Ben. What are your thoughts on security through obscurity? I know that's generally discouraged, but I don't know. I see there's some benefits there, if nothing else, just to make life more difficult. What are your thoughts on that?
Yeah, so I don't recommend it as a valid security tactic in that you should always be secure without it. But I also don't recommend against it for making your life easier or for protecting maybe data that's not super sensitive but still shouldn't be guessed. So I give an example in the book actually of, let's say we're uploading a file and we just have a bunch of uploads. Maybe they're not super sensitive, but you really wouldn't want someone to just type in the next integer and see the next file that was uploaded, as an example. Ideally, though, you would want to actually have like an access control on that. So you say, unless you should see this file, you can't. But a lot of times, a lot of websites, they'll just use some random hash for their ID parameter, for example, so that you can't just guess through the data. So maybe the data is not super secure, but you still don't want people to just be able to watch it live, or for scraping. So, if you have a content-heavy site, if you just use ID integers, it's super easy to scrape that site. You just add to the ID, and then you go scrape that page, and you just add the ID again. And things like that. I wouldn't recommend relying on things like the file. It would be safe using ACL. All right, any other questions?
Do you have any other questions, guys? All right, so I guess that's it for today. Yeah, so thank you very much, Ben, for the great time. That's awesome.
All right. Thanks for coming, everyone. It was great to chat, and hope you learned something.
Yeah, so this will be recorded on Google Hangouts. It will be available on Codementor website soon. So thank you very much, guys.
All right, thanks.
Take care.
Bye.
Bye.